Hello and welcome back to another UE4 tutorial. Today we will be going over objects and programming, how they work, and how to create them in the Unreal Engine. Object-oriented programming is a model that centers around creation and manipulation of objects rather than logic. By objects, I mean instances of a blueprint that outlines attributes and behaviors. Programmers define these blueprints for objects called classes that they can build functionality into and create objects at will. For example, an apple class could create several apple objects that can all be eaten. After the class is created, programmers can then create and individually use multiple instances or objects of that class. Object-oriented programming provides several benefits, including complicated bits of code can be replicated easily, unique behaving classes can be created, and object data may be protected from intrusion, and more. Classes have two main features, which are variables and methods. Variables can be thought of as attributes. These hold data regarding the object created from the class. Programmers may use any and all variables to describe their objects. An example of a variable would be an integer holding the amount of passenger a car has. Methods can be thought of as actions or behaviors. Methods, when called, can do or manipulate anything, but in objects they typically focus on applying changes to its own variables, processing calculations, or interacting with other objects. An example of a method would be a car getting an oil change, where the car object changes its oil variable to new. Keep in mind, once a class has been defined, an infinite number of objects, all with different values, can be made from that class. As an example, we are going to make up an apple class. This will specify the attributes and behaviors of an apple. Some potential variables include the apple's color, red, the apple's size, 12.3 inches, the apple's amount of seeds, 8, and the apple's edibility, which is true. These are all examples of data that describe the apple. Now some potential methods include growing, getting bit, rotting, and getting infested. The growing method might change the color of the apple, while the getting bit method may reduce the size of the apple, and so on. Here you can see the relationship between variables and methods. Now we are about to create a class in the Unreal Engine, but before we do that, we're going to discuss UE4's blueprints. Blueprints refers to classes in the Unreal Engine, and in order to make an apple object, we'll need to create its blueprint. In that blueprint, we will be specifying the variables and implementing the methods. UE4's visual scripting allows for easier readability and usability when creating these classes compared to conventional coding. It also simplifies your job as a developer by handling much of the tedious work that comes with coding. Do know that you can achieve the same results and even create the exact same logic as comparable code written in C++. Even if you are very familiar with C++, I recommend using blueprints as it saves time and eliminates headaches from syntax errors. With that out of the way, let's create the class in the engine. So we're back in our project, and we're now ready to create an apple class. First, let's make a folder in the contents folder to hold all of our blueprints. We'll call this one tutorial stuff. Double click it to open it, and we can create a blueprint inside here. So right click, and you'll see you have lots of options to choose from. But for now, we're going to create a blueprint class. So click that. And you'll see a list of a few different classes that you can choose from. Now there's more if you click all classes. You'll see every class that you could possibly create. But the top ones show you or give you a description of what they are. The top one is an actor that can be placed or spawned in the world, which sounds just like an apple. So we'll go ahead and click that and name it Apple. Double-clicking on our new blueprint will open a new window where we can edit the blueprint. You'll see a plethora of new tools and windows, so we'll just go over those real quickly. The top left, the components window, you can add anything from static meshes to auditory senses for AI. This is where you add components to this blueprint. Below that, you have My Blueprint, which has things such as graphs, functions, variables, that kind of stuff. That's where you add your variables, which are your attributes for the item. On the right, we have a Details panel, which will give you all the details of any components or variables that you have selected. And at the top, we have a standard toolbar, which compile and save are going to be your best friends. But now we're going to want to create an apple. So clicking on the add component thing, we're going to click sphere and name that sphere apple. We probably don't want it to be a blank white color. So looking at the details panel and going under materials, we can see it has basic shape material. We're going to change that to something that has more color to it. You can also transform the figure. I'm going to go ahead and double the size of it and then search for a new material to put on it. And then I'm going to compile. Now this is saved, this blueprint. So if I were to drag this blueprint into a level, it would look exactly like this, and it would have no functionality because we haven't added any yet. We can add functionality by visiting the event graph, which acts as the main method for this blueprint. So at the top next to viewport, click event graph, and you'll see 3 different red nodes. The first one is event begin play. This one will activate and run the code that comes off of it as soon as it plays. Next one, event actor begin overlap, will occur when it overlaps with another object. An event tick will occur every frame that the project runs at. To get started implementing the apple, we're going to create our apple variables. So on the left, under My Blueprint, click the plus sign on variables, and this will create a new variable. This one already has a name and a type. It is a Boolean. We're going to change the name to color, and we're going to change the type to string. You'll notice at the bottom, default value says to compile before you can specify a default value. So we'll go ahead and compile, and since our apple is yellow, we'll put apple as the default color. We're going to go ahead and add 3 more variables for our other apple variables. These are not all going to be strings, as strings hold words. Size is going to be a floating point integer, which means it holds decimal values. Our third variable, seeds, is going to be a integer type. And our last variable, edible, is going to be a Boolean. We're going to have to set the default value for the Boolean to true, as we want the apple to be edible. Compile first, and we'll go through and change the default values for the other variables. Alright, now there are a few things you can do with variables. We want to apply them to the event graph where our code is, so you can simply click and drag the variables over to the event graph, and it will give you 2 options, get size or set size. Getting size will put out a node that basically holds the current value of that value variable, and set will, when called upon, change that current variable to whatever number it is. You can set it to a default value or get a integer from a different place. Now that we have our variables finished, we're going to want to go ahead and create some of our methods. Now remember, a method is called a function in Unreal. You can add one by clicking this function tab. We're going to name this to getBit. because we're going to want to decrease the size of the apple. Now here on the event graph, you have this purple node, which is the start of this function. This will get called, or this will play when the function is called. You can drag off of it and add more nodes. But because we want to decrease size, we're going to right-click and search for decrement float. This will subtract 1 from whatever value or variable we want. So we're going to drag in size, get it, and set it to the decrement. Now the decrement knows what variable it is. It knows its size, it knows its value because we're getting that variable. And so it is going to, when played, subtract 1 from size. Size will then have 12.3 as its value. Great. The functionality of decrementing size for the getBit function is here. But we're not sure if it's going to work. A common debugging method is to print to the console and print values in certain places of code. So we can drag off of, after we decrement, we can search for print string, and this will print something to the console, a message that we make up so that we know what's happening inside our code. For now, we're just going to get size. You can literally just click and drag the new size variable into the in-string thing, and it will automatically convert it to a string from a float for you. So now, after it decrements, it should print the screen 11.3. We can go ahead and drag Apple into the scene. And once we click play, if you look at the top left of the viewport, you can see 11.3. So we know that it is successfully decremented the value. But aha, I have tricked you. There was no 11.3 in the top left. That is because we have not called this function that we have created. In order to do that, we'll have to go back to the event graph and either create a custom event or use one of the 3 events that we have. We'll just use event begin play so that as soon as we click the play button, it will call the getBit function. Now everything in the getBit function will run once, so we'll decrement the value of size once, and then it will print to the screen. So now if we compile and go back to our level and click play, you should see at the top left 11.3. There it is. And so it's successfully decremented the size value. That was your introduction to blueprints. For the next meeting, we're going to go ahead and do a little prep work and create a new level that you guys will be editing in the next tutorial. So go to your content browser and create a new folder, just like before, but name it levels. Open it up, right click as if we were going to create a blueprint class, but click level. New world is a fine name. You can double click it to open it. And oh my, it is a very dark world. This is a new level with literally nothing in it. You're going to need a few things to get started, one of those being a sky sphere. Now you'll notice that the sky is quite orange, and if you look at the bottom right, the color is blue. You might be confused, but this sky sphere will automatically change colors with the sun. So right now the sun is setting, so it's orange. If we go to sun height in the details panel, click and drag, we can put it at the top of the sky, making everything nice and blue like it was before. Another thing we're going to need is a plane for us to walk on. So we'll go ahead and drag one in. It is fairly small. We're going to put it at the world origin 0, 0, 0, and then increase it by a factor of 10. So the scale on X and Y from 1 to 10. Now we can put any kind of material on this thing to make the floor whatever we want. I'll look for some bricks. These come with the first person template. But you notice it's black. Well, that's because we don't have any lights. So we'll drag in a directional light, which acts as kind of like a sun light. A light that acts as the sun pointing down. And now that we can see our places lit up. One more thing that we'll need to play in the level is a player start. When we click play, this will automatically spawn us at this place with our selected character blueprint. And now we can run around. You might notice a red error in the top left that says that lighting needs to be rebuilt. Whenever you add new objects or new lights in the world, the system will have to recalculate shadows and lighting. So you can go to build and click build lighting only, and this will regenerate the light and shadows for all the objects in the scene. Once it's done, you'll notice a slight change, but not that much because we don't have anything but a plane. But now the lighting is rebuilt. And congratulations on completing the second tutorial. In the next one, we'll be working with levels and designing geometry. But until then, good luck.